This is Team Gilbane's CEE 420's term project. In this report, our team studied the ongoing construction at the intersection of 4th and Green. Specifically, we observed a crew pouring a concrete slab. After videotaping this activity from a higher vantage point, our group of experienced construction professionals analyzed the data and proposed several improvements that could be made to increase the efficiency and output of this crew. An initial crew balance was drafted in order to use it as a base for improvement. Each plan's efficiency was then measured in percent cost savings compared to the observed. A flow diagram and process chart were also created to better understand the specific task and inherent difficulties that the activity presents. Each of our 3 improvement plans aims to reduce idle time in a separate manner. These range from increasing work output by pouring twice per cycle to reducing the workforce and combining responsibilities. The results of these plans showed implementation of such measures could yield a productivity between 1.23 to 1.53 times greater than the operation that was observed. When starting this project, our primary objective was to monitor a construction activity that the entirety of the group has had previous experience with, as well as be easily accessible so that we could film the construction crew at work. We decided that we would observe a crew pouring a concrete slab for the 2nd floor of a new high-rise apartment building. Our group then documented and analyzed the different techniques used by the crew to pour, spread, and smooth the concrete. This new apartment complex will be located on the northwest corner of 4th and Green Street in Champaign, Illinois. Once the apartment building is complete, it will consist of 143 units, a ground floor cafe, and a state-of-the-art parking system with a car elevator. Here in Champaign, LLC is the developer for the project, while Clayco Corp was chosen as the general contractor. While we didn't actually step foot on the construction site, we did film from a high vantage point across the street with perfect line of sight on the concrete work. We had the luxury of filming the construction from the safety of an apartment bedroom overlooking the construction site. Once this location was set, we simply needed an ideal date to film. We obtained the date of concrete pouring from the site crew in order to prepare to film the site on a high-density workday. This would assure high worker volume and fair weather conditions. The camcorder was set up in the location pictured above and aimed down towards the construction site. We began the footage around 8 a.m. and continued filming until 11:30 a.m. At 11:30 a.m., we repositioned the camcorder to focus on the area where the concrete pouring was occurring, which is the southwest corner of the site. This allowed for much easier analyzation of the video later on to formulate our crew balance charts and proposed project improvements. The operation of the pouring of the concrete consists of arrival and placement of pump truck, arrival and placement of cement truck, the connection to pump truck, the hose of pump truck being placed accordingly to the pour location, pumping of concrete to location, filling of bucket next to the cement truck, bucket moved up to pour location via tower crane, dumping of concrete at chosen location, spreading of concrete, addition of sand for cohesive purposes, smoothing of concrete, curing, and inspection and progression. To analyze this operation, we used industry-standard construction management techniques. These techniques included a 5-minute rating, which helped to show how efficient the crew is being throughout the task, along with a process chart and flow diagram. After analyzing all this information, a crew balance chart was constructed and analyzed. After the construction of the crew balance chart, our team saw a clear relationship between all workers. Once the entire process and all relationships between workers and equipment were understood, proposed productivity improvements were made. These improvements were designed so that the current cycle time would be reduced, and crew productivity would be increased. And proposed changes were then shown with modified crew balance charts. After modifying the crew balance charts, our team then determined hourly wages for this crew and showed the saved costs and productivity increases these improvements would create. The crew consisted of 12 workers who each worked on one task. The main tasks were pouring, spreading, and improving concrete. The concrete was poured in sections. The construction method observed at 4th and Green was a fairly typical concrete construction. At the time of observation, the crew was working on second-story slab. All of the formwork and steel reinforcement was already placed, and the crew was working on pouring, spreading, and smoothing the concrete to let it cure. During the observation, 2 different types of methods were used. The crew both pumped concrete from a pump truck on the side of the site and dumped concrete from a bucket that was suspended from the tower crane that was already on site. The crew primarily used concrete pumped up from the pump truck on the side of the construction site, but did resort to the use of the dump bucket to reach the far corners of the site and a few other areas that were either too awkward or far away from the hose of the pump to reach. As the concrete was poured, several workers of the crew spent time spreading and smoothing the concrete, as well as applying layers of sand to help the various aspects of the concrete during smoothing. These processes were repeated until the second floor slab was poured and left for curing before beginning on the next level. One worker spread the concrete using a hose that was connected to a pump. 2 workers, using backpack vibrators, then inserted the vibrating head into concrete in order to spread it. They followed the worker pouring the concrete, vibrating the freshly poured material. 3 workers then used handle-mounted leveling tools to spread the concrete, following the workers using the vibrating tools. 2 crews of 2 workers then get on their knees and use 2x4 wood boards to level the concrete. 1 crew followed the worker spreading the concrete with the handle-mounted spreading tools, and the other worker, perpendicularly to the crew, got the areas they missed. Once the entire concrete section was poured, 2 workers placed a plywood board onto the concrete, then moved a wheelbarrow filled with the sand into the board. Then 1 worker held the wheelbarrow, while the other used a shovel to throw the sand onto the recently poured concrete. The 2 workers would then place another plywood board and move the wheelbarrow, repeating the process until the entire section was covered. Another worker then took a long broom to spread the sand. 3 problems that we look to solve include too much idle time, cycle time efficiency, and the number of workers for each task. For Project 1 improvement, we focus on training the workers to perform multiple tasks, which increased training allows workers to minimize the idle time, therefore increasing productivity. In order to simplify the 25-minute construction cycle, the workers are categorized into 4 groups. Workers 1 to 3 pour concrete, workers 4 to 6 spread concrete, workers 7 to 10 level wood, and workers 11 to 13 place and sweep sand. These groups' schedules will be manipulated in order to maximize productivity. Here's a diagram of the simplified group crew balance. Cycle idle time can clearly be reduced. Workers 1 to 3 have enough time to complete a second pour per cycle. In order to retain the 25-minute cycle time, the remaining task capacity must also be doubled. Workers 4 to 6, the concrete spreaders, have enough idle time to complete a second round of workers 11 to 13's task. Workers 11 to 13, the sand placers, have enough idle time to complete a second round of workers 4 to 6's task. Dual training these workers will allow for 2 pours per cycle without increasing labor. The remaining labor group is wood levelers. The current crew cannot accommodate 2 pours per cycle. Therefore, this crew must be doubled from 4 to 8 workers. As you can see, This is our improved group crew balance, which allows for 2 cycles during the time frame that it would take them to complete 1 cycle. By training the workers to know 2 different tasks, we are able to optimize the amount of time in the process. The cycle adjustments result in a doubled output per cycle, measured in cubic yards of concrete. 4 workers were added, increasing the total from 13 to 17. Our input per cycle measured in man-hours increases from 5.42 to 7.08. This results in an overall system that is 1.53 times as productive. In the current cycle, there are large segments of time when workers are standing around idle. This idle time can be reduced by eliminating some of the workers from the workforce. However, it does slightly increase the overall cycle time. Improvements can be made to the cycle by eliminating workers 9, 10, and 12. Workers 7 and 8 are already trained in the task for 9 and 10, so they simply add it to their task, increasing their time by 0.25 minutes. Worker 4 can take over for Worker 12, as there is no training required for Worker 12's task. Here is the example of a crew balance for this improvement. These improvements result in an increase in schedule of 2.5 minutes, making it a 26.5 minute cycle. They also eliminate 3 workers from the project. The new schedule takes 4.4167 man-hours per cycle, which is more efficient than the old cycle, which took 5.4167 man-hours. This is a total productivity increase of 1.23. This current process has workers 1, 2, and 3 occupying from start to minute 7 and idle until the end of minute 25. It also has workers 11, 12, and 13 idle from the start to minute 18 and then occupying until the end at minute 25. This causes the 6 workers to have a total of over 2 hours of inefficient work being done. To improve this process, we have suggested that management should eliminate workers 1, 2, and 3 and replace their tasks by workers 11, 12, and 13. Since there is no overlap in time of the tasks being done, workers 11, 12, and 13 can pick up the new work without increasing the total time of the cycle. The decrease in crew members from 13 to 10 results in the productivity of the process being 1.3 times as great as the current process. After fully investigating all the options, our major suggestion to Clayco is to increase productivity by decreasing idle time. Our improvement plans examined the potential of both force reduction and increase in production to achieve this goal. Of all the improvement plans, Improvement 1 created the most significant impact. It took the radical measure of adding 4 laborers, which allowed for a doubling of the cycle output. The increased output required all workers to be on their game and reduce idle time to less than 5%. This improved productivity by a factor of 1.53.